For our Introduction to Deep Learning project, we focused on enhancing DALL-E to recognize vertical spatial relationships.
DALL-E is a new text-to-image generating system that OpenAI has released to the public. The eye-catching feature of DALL-E is its ability to combine unrelated concepts in plausible ways. This ability to generate images on text that the model was not trained on is termed zero-shot image generation and sets DALL-E apart from previous generative models. However, DALL-E has imperfections. Our group focused on one specific imperfection: spatial relationships. For example, DALL-E has trouble with phrases such as a cat to the left of a dog. This example is exemplified in the bottom left, where the cat is actually above the dog. DALL-E performs even worse when relationships become complicated, as shown on the image on the right. Evaluating spatial relationships is something that has been performed in the past using capsule networks and relational networks. These areas of study were our primary focus of research, and we eventually decided to rely on a relational network architecture to enhance DALL-E. But our project was novel in that we aimed to improve DALL-E by combining the concept of a relational network with the image generation task. We try to improve DALL-E's ability to recognize vertical relations and assume that the results can be extrapolated to other spatial relationships. As mentioned earlier, DALL-E excels at generating images that are not plausible or not seen before, whether it be for video games, architectural visualization, etc. Improving the realism of these images is certainly something valuable and something generative models should strive for.
To train our models, we generated a dataset of images with each image containing 6 2D objects and 15 object pairs, with each pair's spatial relationship described by a question. For example, is the orange circle above a gray circle? Each question would then generate a sentence that would be used to train DALL-E, while the object pairs and questions were used to train the relational network.
Here is an overview of our method. First, we trained DALL-E model to generate images, and we trained relation network model to identify spatial relationships between objects in the image. Then we filtered the generated images by selecting those with the correct spatial relationships with the help of relation network. Specifically, our project focused on a single relationship above. For DALL-E, we used the open source implementation to train the model on our dataset. With input sentences in the format x is above y, we run DALL-E model to generate images with simple objects. Relation network is a model that predicts the answer to a relationship question considering all the object pairs. We train this network to answer the question, is x above y, based on the information in the associated input image. Here is an example of how our method works. We have a sentence, an orange rectangle is above a red rectangle. We let DALL-E generate an image based on it. If relation network predicts that the orange rectangle is not above the red one, we let DALL-E to generate another image. We repeat this process until relation network predicts the statement to be true. There is limited previous work done in this area. The novelty of our idea is to utilize the power of the spatial classifier to improve image generation results from DALL-E. In addition, our methods have several advantages. Our method is flexible to utilize different spatial classifiers with minimum modifications of the workflow. As a proof of concept, our project is limited to a single relation above. However, our method can be generalized to other relationships as well.
In order to verify the effectiveness of a spatial classifier with DALL-E, we ran an experiment to compare this DALL-E model we trained for our baseline model. We had each model generate text-image pairs, which we split between ourselves to perform human evaluation on. DALL-E combined with the relational network classifier saw a 6% increase in text-image pair accuracy. To illustrate the improvement, here is the contrast between the resulting image generated by each model for the text input specifying an orange rectangle being above a red rectangle.
The overall improvement seen by applying relational networks as a filter on top of DALL-E indicates that this is an area of improvement worth looking into. However, since DALL-E had not been trained for very many epochs, it would be interesting to explore the effects of relational networks on higher quality images.
We would like to thank the following repositories and individuals for helping us create our baseline models. Finally, the source code for the project with pre-trained models can be found at the link at the bottom. Thank you for your attention.